Hi everyone, this is Vijay Chandu from CSC AML branch. Today I'm going to explain about graph databases for knowledge management. With the advancement of emerging technologies, knowledge management continues to assume an important role in organizations. The latest technologies developing have transformed the traditional landscape of organizations, technological infrastructure, enabling them to seek innovation ways to manage their internal knowledge assets. For instance, the Internet of Things (IoT) enables ubiquitous continuity connectivity among intelligent devices, allowing real-time data to be collected, shared, and stored. Big data possesses challenges for organizations in collecting and utilizing huge amount of data, but also creates opportunities for them to capture and discover new knowledge to facilitate further development. Among emerging technologies, NoSQL database have been became popular alternatives to traditional relational database due to advantages such as flexibility, scalability, efficiency, and the ability to handle large amount of unstructured, semi-structured, and structured data. A special type of NoSQL database, graph database have the same advantages. In addition, graph databases are particularly useful in handling data elements that have complicated relationships. Due to their unique features, graph databases have been widely applied in various areas such as fraud detection, real-time, etc. Knowledge management process model. Knowledge management can be implemented as a series of processes in organizations to be consistent with the traditional landscape of knowledge management. The following processes moderated by the knowledge management system are considered in this research. First, knowledge needs to be discovered either from existing documents as explicit knowledge or as tacit knowledge from knowledge workers who have expertise and then capture and created. Second, knowledge must be codified and stored for future retrieval purposes. Third, knowledge needs to be transferred and shared. Depending on the nature of knowledge, different processes will be used. Especially, explicit knowledge contained in existing documents can be easily transferred to knowledge seekers, whereas tacit knowledge needs to be shared among knowledge workers. Finally, knowledge obtained by recipients will be applied in specific tasks, and knowledge used will be assessed for its quality and performance. Here, the figure shows a data flow diagram of a major process the system supports. Process allows knowledge workers to register their new enterprise and update their existing expertise listed in system. Data stored D1 maintains an expertise directory for all the knowledge workers in the organization. Process 2.0 enables knowledge workers to search for existing knowledge residing in organization, either the explicit knowledge manifested by the document stored in the respiratory or the tacit knowledge associated with one or more knowledge workers. Keywords are attached to the document or the knowledge worker so that people can use them to search for a specific piece of knowledge. Data storers D2 and D3 are used to store the explicit knowledge and the metadata for tacit knowledge. That is the knowledge workers who possesses specific tacit knowledge. Processes 2.0 and 3.0 facilitate the matching process of locating a particular document or an expert based on the original request. Here is the diagram. Data flow diagram of a knowledge management system. The system supports several major processes, including maintaining an expertise directory and letting knowledge workers search for existing organizational knowledge. Relational data model. Following on the process model, the computational data model can be developed to reflect the situation when a relational database design is adopted. To be consistent, the data stores model in figure 1 should be considered in the conceptual data model. Figure 2 demonstrates the relational conceptual data model in which four entities are created to reflect the process facilitation needs shown in figure 1. Here is the figure 2. The expertise entity stores a list of expertise keywords and their descriptions. The knowledge worker entries captures important information about knowledge workers The document entity keeps the major characteristics of each document, such as its document ID, name, description, and type. The worker's expertise entity is essentially an associative entity that matches a worker with his or her specific expertise keywords, which can be added and updated at a specific time. The relationship among these four entities are quite complex. Worker's expertise reduces the original many-to-many relationship between knowledge worker and expertise to one-to-many relationship between knowledge workers and workers' expertise and between expertise and workers' expertise respectively. To implement this conceptual data model in a relation database management system, RDBMS, all the many-to-many relationships need to be further reduced, which means additional relations need to be introduced. Because there are currently two binary and three unary many-to-many relationships, five additional relations should be constructed to fully implement the data model in an RDBMS. It is evident that the implementation of this data model is quite cumbersome. In addition, the newly introduced relationship will negatively influence the response time of the queries searching the database because individual tables need to be joined to return the results of each query. The next section describes how a property graph data model can avoid these potential problems in a relational data model. Property graph data model. A graph database can be conceptually illustrated through a property graph data model. A property graph contains all the interconnected nodes used to hold the attributes that describe each node. One special aspect of graph data model is that all the nodes can be tagged with labels to indicate their roles in the domain. The labels contextualizing role can be effective in modeling the different roles assumed by a knowledge worker in an organization, which is an additional benefit of applying graph database in this situation. A relational data model can be easily converted to a property graph model. Figure 3 shows the property graph model converted from conceptual relation model. This is figure 3. The property graph model of the knowledge management system, a relational data model, can be easily converted to a property graph model, such as this one. In figure 2, because a many-to-many relationship can be easily implemented, there is no need to specially model the worker expertise node. Instead, a many-to-many relationship can be directly modeled between the knowledge worker and expertise nodes. Two properties, data created and data updated, can be attached to this relationship to indicate when a knowledge worker creates and updates his or her expertise items. Finally, only three nodes, knowledge worker, expertise, and document, are needed with a many-to-many relationship between any two of them. In addition, each node has a many-to-many relationship with itself. Implementation. The implementation of the property graph model can be straightforward. Neo4j Community Edition was chosen as the graph database management system to demonstrate the following example. See in figure 4. This is figure 4, graph database example using the Neo4j graph database management system. Nodes and arcs can be easily created using Neo4j query statements. See in figure 4, which includes 3 knowledge workers, 3 documents, and 3 enterprises items in database. In addition, there are 22 arcs that describe how these 9 nodes relate to each other with many-to-many relationships. Here are the 9 nodes and 22 arcs. For instance, expertise 1, EXP1 relates to EXP2, which further relates to EXP3. Document 1, DOC1, Doc1 links to Doc2 and Doc3, and Doc2 links to Doc3. The nodes and arcs can be easily created using Neo4j query statements. As an illustration, figure 5 demonstrates some source code to create the nodes of document 1, knowledge worker 1, and expertise 1, as well as the arcs between worker 1, document 1, between worker 1 and expertise 1, between document 1 and document 2, between document 1 and document expertise, between expertise 1 and expertise 2, and between worker 1 and worker 2. When new knowledge worker expertise items and documents need to be added, the query can be quickly expanded to insert the new nodes and ask into the graph database. Here is figure 5 with some queries. Finally, two sample queries shown in figure 6 are used to illustrate the processes that can be facilitated to allow knowledge workers to search the graph database for specific expertise item. Query 1 can search for all the existing documents that match a particular expertise keywords. EXP1 in this example, if no such document is available in the system, then query 2 can be used to look for available knowledge workers who can provide such expertise. Additional queries can be developed to explore the relevant documents linked to each other and similar expertise available in the system, given that no such expertise items and documents are found in current database. Knowledge management continues to assume an important role despite the changing landscape of technologies, infrastructure, and organizations. Emerging technologies provide opportunities for companies to manage their knowledge assets with more innovative and effective methods. Relational databases have been the core components of knowledge management systems to facilitate common knowledge management process in organizations, including knowledge capture, storage, transfer, and application. Due to the complex nature of this process, it is cumbersome to design, develop, and implement a system based on relation databases to facilitate them. Graph database can be good alternative to traditional relational database as a core component of a knowledge management system because of their special features. First, graph databases are ideal for modeling scenarios in social network text in which knowledge management processes are well represented. Second, the many-to-many relationships in the relational database can be easily implemented as arcs in the graph database without introducing additional nodes. Third, the data stored in a graph database can be quickly accessed through the simple queries, whereas multiple tables must be joined in a relational database for the same purpose. And thank you.